Hello friends, myself Rajendra Mahajan presenting my video on Jacobian. Let us solve the problem. Find Jacobian of the following transformation. At point 1 minus 1 0 given u is equal to x plus 2y square minus z cube, v is equal to 2x square yz and w is equal to 2z square minus xy. To find the Jacobian, we apply the definition of Jacobian. J is equal to dou of UVW divided by dou of XYZ. Means we have to obtain the determinant containing this derivatives of UVW with respect to XYZ. Therefore, in first row, dou u by dou x, dou u by dou y, dou u by dou z. Second row, derivative of V with respect to x, y, z. And in third row, derivative of W with respect to x, y, z. And after obtaining this derivative, we have to evaluate this third order determinant is the Jacobian and then find its value at that point. Therefore, performing the calculation, differentiating u with respect to x, its derivative is 1. Differentiating with respect to y, we get 4y, and differentiating it with respect to z, we get minus 3z square. Substituting that determinant, we get 1, then 4y, and then minus 3z square. These are the derivatives of u with respect to x, y, and z, partial derivatives. Then differentiate it with respect v with respect to x, then y, and then z. Derivative of v with respect to x is 4xyz. Then differentiating it with respect to y, we get 2x square z. And with respect to z it is 2x square y. These are the partial derivatives of v with respect to x, v with respect to y, and partial derivative of v with respect to z. Then finally we have to differentiate w with respect to x, its derivative is minus y. Then differentiating it with respect to y, its derivative is minus x. And derivative of that term with respect to z is 4z. Therefore, partial derivative of w with respect to x, then with respect to y, and then with respect to z. And then we evaluate this third order determinant as usual. We are evaluating the third order determinant. First element 1 into neglecting first one, first column, determinant of this remaining 4 elements. Therefore, product of 4 to the 8, x square, z square, minus, and this minus, it become plus, product of these two, that is 2x cube y. Then second term with minus sign, minus 4y. Neglecting first one, second column, determinant of 1, 2, 3, 4 elements. Therefore, product of these two, it is 4 into 4, 16, x, y, z square, and minus, and this minus, it become plus 2x square y square. And then plus third term is with minus sign, minus 3z square. This time we neglect the first row and third column, determinant of these 4 elements. Therefore, product of these two, it is minus 4x square yz, and minus, and this minus, it become plus 2x square yz. Therefore, this is the value of that determinant. Without simplifying it, we substitute the values of that point. X is 1, y is minus 1, and z is equal to 0. Therefore, we find at 1, minus 1, and 0 the value of g. Therefore, as z is 0, this term becomes 0. Therefore, we have 1 into 2 into x cube. X is 1, 1 cube is 1, and y is minus 1. Then minus 4 into y, the value of y is minus 1, multiplied by, again there is a term of z, therefore this term becomes 0, this term becomes 0. Second term becomes 2 into x square, 2 into x square, 1 square is 1, and minus 1 square, it is 1. And this is, outer term is 3z square. Therefore, as z is 0, this complete term becomes 0, and therefore minus 0. Simplifying it, we get 2 into 1 into minus 1, we get that value as minus 2. Minus minus, it becomes plus. 4 to the 8, and minus 0. And therefore, value of that Jacobian at that point 1 minus 1 0 is 6. This is the required answer. A very simple problem. Only all of you must be able to find the partial derivatives correctly. Therefore, be careful while performing the partial derivatives. Total 9 derivatives we have to obtain, and then find that value at the point 1 minus 1 0. We get that value as 6. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.